Hi guys. Okay, so today we're going to talk about multiplication of rational expressions. All right? So, the first thing we do in this first problem would be to multiply numerators and denominators. Now, we don't need to do it in this particular problem, but I would say there's usually a step before this, and that is to factor. Factor anything that you can. Obviously, in this problem, there's nothing to factor, so we don't have to worry about it. But in the next problem, we will. So the first thing we're going to do is we're going to multiply, and we multiply across. We multiply top by top, bottom by bottom. So 2 times 6 is 12. Now the x's, remember when you multiply, you add the exponents. So 2 plus 2 is 4. All over, 3 times 12 is 36. And again, with the x's, we add the exponents. 1 plus 4 is 5. There we go. So the next thing to do is to factor and to divide out any common factors. So if we look here, what goes into 12 and 36? 12 goes into 12 once and into 36 3 times. Okay, so notice in the top, we only have a 1 for the numbers. In the bottom, we have a 3. Now let's look at the x's. When we divide, we subtract the exponents. So we have a 4 and we have a 5. If we subtract them, we get 1. Now where does that x to the first go? Does it go on the top or does it go on the bottom? Where did we have more? We had more on the bottom, so the x goes on the bottom. That's one way to think about it. The other way is the exponent in the numerator was 4 minus the exponent in the denominator is 5, so you have an exponent of -1. If it's a positive number, it goes in the top. If it's a negative number, it goes in the bottom, and it would just be x to the first. Okay? I know that's a little tricky. We'll get there. Oh, and we even did the third step, which was to simplify, and we're done with this problem. Okay, let's try another one. Okay, example 2. Example 2, we have 3x squared plus 3x over 4x squared minus 24x plus 36 times x squared minus 4x plus 3 all over x squared minus x. There's going to be a whole lot of factoring going on. Okay, we start on the top of the first fraction. There is a greatest common factor. Each term has a 3, and each term has an x. So we are factoring out a 3x and then opening parentheses. Now 3x squared divided by 3x, the 3's divide away to 1, and the x squared divided by x is x to the first. Plus, now I have 3x divided by 3x, and that's just 1. Now in the bottom, again, there's a greatest common factor. What number goes into 4, 24, and 36? That would be 4. So I'm going to factor out this 4. 4x squared divided by 4 is x squared minus 24x divided by 4 is 6x plus 36 divided by 4 is 9. And you know what? That's going to factor some more even. You see that trinomial? I am factoring. Okay? We're going to have 2 parentheses. And because it's an x squared, I'm going to have an x and an x. I need 2 numbers that multiply to a positive 9, so they're going to be the same sign. And they're adding to -6, so they're both going to be negative. And let's think about these factors and sums. Multiplies to 9. That's a 1 and a 9. And make them both negative. That adds to -10. Not what we wanted. 2 does not go into 9, but 3 does, and it goes in 3 times. They're both negative. We add them up, and we do get -6. That's the pair we want. So we have a -3 and a -3. And we can put a line right through this now because we just changed it. All right, times. Now we need to factor the top, x squared minus 4x plus 3. Guess what? That's another trinomial factoring happening here. So we're going to need two parentheses again. We have an x squared with an x in the middle, so we need x and x at the beginning of each. We need two numbers that multiply to a +3. Now, if they're multiplying to a positive number, the signs are the same. They're both going to be negative. Now, this shouldn't be too hard because the only numbers that multiply to 3 are 1 and 3. And if they're both negative, do they add to -4? Yes, they do. So we have a -1, -3. Wow. Okay. Now we're going to do the bottom one. Do we have, look at this, we have a greatest common factor. What do they both have? They both have an x. So we're going to write an x and we're going to open parentheses. X squared divided by x is x, minus x divided by x is 1. Whew. Okay, now we're going to multiply across everything that was in the top. A 3x, an x plus 1, an x minus 1, and an x minus 3. All we did is take everything that was in the top and write it in the top of one fraction. Now everything that was in the bottom, a 4, an x minus 3, an x minus 3, an x, and an x minus 1. Now we're looking for things we can cancel out, and they have to be exact matches. Let's see. Ooh, I see an x and an x. They're going to go away. I see an x plus 1 in the top, but no x plus 1 in the bottom. I do see an x minus 1 in the top and the bottom. And I see an x minus 3, top and bottom. Now if I look, let's check. The only thing left in the top is 3 times an x plus 1. And in the bottom, I have a 4 times an x minus 3. There's nothing that goes into 3 and 4, and those are not exact matches with the x plus 1 and the x minus 3, and you can't cross out just part of it. So there it is. Okay, let's try another one. Okay, so let's try another one. First thing we're going to do is we're going to factor. Cannot factor 8, but b squared minus 9 is a difference of 2 squares. The square root of b squared is b, and the square root of 9 is 3. So we're going to have a b plus 3 and a b minus 3 times, now my second fraction, the denominator is 8. That can't change. But in the top, what goes into 6 and 18? That would be 6. So I'm going to write that 6. Now 6b divided by 6 leaves me with a b, minus 18 divided by 6 leaves me with a 3. Now I'm going to take everything I have, everything in the top. 8 times 6 is 48. Keep the b minus 3. In the bottom, I've got a b plus 3, a b minus 3. I'm going to put the 8 up front because I always put numbers up front. Okay. Any exact matches? Well, I see b minus 3. Now, numbers, you have to actually think a little more. What number goes into 48 that also goes into 8? 8. 8 goes into 8 once. 8 goes into 48 6 times. Okay, what's left? I have a 6 up top, and in the bottom, all I have is b plus 3. I cannot divide that 3 into the 6 because the 3 is attached to the b. We're done with this one. Let's try another one. 3p squared over 5p plus 25 times p squared minus 2p minus 35 over p minus 7. Now 3p squared gets no simpler than that. There is a greatest common factor in the denominator though. What goes into 5 and 25? That would be 5. So if I take out a 5, 5p divided by 5 is p, plus 25 divided by 5 is 5, times. Now the bottom of this one isn't going to get any simpler. P minus 7, that's as simple as it's going to get. But the top is a trinomial, and we're going to have a p in the front and a p in the front. And we need to multiply to a negative 35, which means the signs are different, and the bigger one's going to be negative. So a small positive and a big negative. And let's think about our factors and their sums. Well, let's see. 1 goes into 35 times, and I make the small one positive, the big one negative. That's negative 34, not what we wanted. 2 does not go into 35, 3 does not go into 35, 4 does not go into 35. Hold on, 5 does. 5 goes in 7 times, make the 5 positive, the 7 negative. They add to negative 2. That's the pair I want. So I put a plus 5 minus 7. Now I'm going to write everything that I have in the top. 3p squared times p plus 5 times p minus 7. And in the bottom, I have 5 times p plus 5 times p minus 7. Okay. 3 and 5, nothing's going to go into them. I do have an exact match with p plus 5 and p plus 5, and also p minus 7 and p minus 7. What's left in the top? 3p squared over 5. That is as simple as this is going to get. Okay, now this next one is real important. Okay, this is a real important one. Well, the first fraction, we're going to keep this, x minus 1 over 1 minus x. We're going to keep that for now. The second fraction, there's a greatest common factor here. What goes into 2 and 16? That would be a 2. And they both have a common x. So we're going to take out a 2x. 2x squared divided by 2x is x. 16 divided by 2 is 8, and the x's will divide out. In the bottom, we have that x plus 8. Notice, and some of you might see it right here, that these x plus 8's cancel out. That's okay if you see it there, and you want to cancel it out before we multiply across, because as long as they're right on top of each other, that's fine. Now what I want to talk about for a minute is this x minus 1 over 1 minus x. When you switch around subtraction, there's an interesting thing that happens. I want you to think 5 minus 3 is 2, right? Now if I switch around the subtraction and do 3 minus 5, that's negative 2. And if we divide them, we would get negative 1. If you switch around subtraction, you will always get negative 1. If it's addition, though, 5 plus 3 is 8, and 3 plus 5 is also 8, so that's 1. If you switch around addition, they reduce to 1. But if you switch around subtraction, they divide to negative 1. And that's important because this x minus 1 over 1 minus x divides to negative 1. So we have negative 1 times 2x, and the only thing left in the bottom is just 1. So negative 1 times 2x is negative 2x, and we never leave it over 1. We're done. That's as simple now as it gets. Okay, we will talk more about that as we go on, but I wanted you to at least see that and hear that, and that's really important, that when you switch around a subtraction sign, it divides to negative 1. One more problem. Okay, last problem for the night. We're going to keep that x minus 2. It gets no smaller than that. Now x squared minus 11x plus 28, that's a trinomial. We're going to need an x in the beginning of each. I am factoring. My two numbers are going to multiply to a positive 28, so they're the same sign, and they're both going to be negative, so that they add to negative 11. Now the numbers that are factors, 1 goes into 28, but we're going to make them both negative 28 times. That adds to negative 29, not what I wanted. 2 goes into 28, 14 times. They're both negative. They add to negative 16. Still not what I want. 3 does not go into 28, but 4 does. 4 goes in 7 times, and when I add that, there's the negative 11 that I want. So I have x minus 4, x minus 7. Now the next fraction, the bottom, x plus 5, is not going to change. But the top, that's the same trinomial I just factored. I'm going to get x minus 4 times x minus 7. Now when I multiply across the top, x minus 2 times x minus 4 times x minus 7, and in the bottom I have x minus 4 times x minus 7 times x plus 5. My x minus 4's cancel, my x minus 7's cancel, and I am left with x minus 2 over x plus 5. Okay, guys, we're going to stop here for today. Have a great day. See you soon.